In this video, we're going to go over how you can verify that two equations are inverse functions by using the process of composition. So in composition, what we're doing is we are plugging a function into another function. So you'll often see it kind of written like you see down here, where we've got f of g of x. And what this tells me is that I'm going to plug g of x into f of x. Sometimes it can be helpful to think, remember when we see f of x, right, that essentially is just y, but the reason it's written as f of x is because it can tell us what we're plugging into the function. So like, for example, if you saw f of 3, you might know that that means you're supposed to plug 3 in for x. So down here, where we see f of g of x, that means that we're going to plug g of x in for x. So let's actually look at doing this problem together. We've got f of g of x. So that means that I'm going to take the f of x function, which is 3 to the power of x minus 1 plus 5, and I'm going to replace x with g of x. And I'm going to leave everything else in the function the same, minus 1 plus 5. So I've only replaced x, and I've replaced it with g of x. Now, g of x, the function, is log base 3 of x minus 5 plus 1. So that whole equation right there, that's what we're plugging in for g of x. So that would be 3 to the power of log base 3 of x minus 5 plus 1. And then we need to bring down the original equation of f of x, so minus 1 plus 5. Now from here, we want to simplify. So I notice if I start with the exponent, since that looks pretty big, so some things might simplify here, I have plus 1 and minus 1. Well, plus 1 minus 1 would equal 0. So then we're left with 3 to the power of log base 3 of x minus 5 plus 5. All right, now looking at this a little bit closer, what we're left with, we have 3 to the power of log base 3. So remember when we have an exponential raised to the power of the log, and they're the same bases, that those two will cancel each other out. When they cancel, whatever was inside of the log now comes out of the exponent. So it becomes x minus 5 plus 5. Well, minus 5 plus 5, that would equal 0. So we are left with f of g of x equals x. And that's good. That's what we want to happen. So now we're going to have to check g of f of x and see if that one also equals x. So let's come on over here. So this time we're plugging f of x into g. So we're going to start with the g of x function, which is log base 3 of x, but for x we're plugging in f of x. Bring down that minus 5 plus 1. Now f of x is the function 3 to the x minus 1 plus 5. So that's what we're going to plug in for f of x. So we will get log base 3 of 3 to the x minus 1 power plus 5 minus 5 plus 1. All right, and now it's time to start to simplify. Looking at this long piece inside the log, I notice that there's a plus 5 and a minus 5. Well, plus 5 and minus 5 would equal 0. So we're left with log base 3 of 3 to the x minus 1 power plus 1. Now again, with logs and exponentials, if you have a log and then you have an exponential inside that log that has the same base, then the log and the base of the exponential will cancel. So the whole log base 3 of 3 cancel. And the exponent that was inside the log now comes out of the exponent. It becomes x minus 1 plus 1. Well, minus 1 plus 1, that would equal 0. So we are left with g of f of x equals x. And now on both sides we have gotten x, and so yes, these are inverses. It has been verified.